welcome to your first lecture. So for our first lecture, we're doing chapter 4, the structure of the atom, and section 1, early ideas. So before we get into that, let's look at a sample of our notes. So again, this is how we like your notes structured on a loose leaf paper in case you forgot or we didn't specify in class or you weren't in class. So 4.1, it's going to be the early ideas about matter. That's going to be your title slide, and then the chapter is going to go around here. And if you want, you can put the date. And then right underneath is your objective. Always, always your objective. And then the title of the slide. So let's go back to our slides. You'll see, so it says objectives. This is just vocabulary before you go. It's chemistry, but like it says early ideas about matter, or early thoughts about matter. That's where the bigger, so early ideas, ancient Greek philosophers. And we go back to our notes. So again, early ideas or thoughts about matter, ancient Greek philosophers, John Dalton. So those are going to be our title slides. And then these notes underneath are going to reflect the notes you take, either that are on the slides or that I say. So the nice thing about having the video lecture, you could go at your own pace. I'm going to try to upload onto YouTube, I believe, or I'll upload it as a files. I've trying to upload on YouTube because you can actually slow it down or speed it up and kind of put it at your own pace. Also, you could put I think you could caption it and put it in the language that you like. So let's start the lecture. Oh, also, I'm going to be uploading the outline onto. Sorry, I already showed you the sample notes outline. So your objective. So students will be able to explain how early philosophers, especially Jake Dalton, contribute to the modern theory of atoms. And then students will know how the law of conservation of mass contribute to Dalton's atomic theory. So the three key vocabulary for this section is matter, Dalton's atomic theory, law of conservation of mass. So guys, your vocabulary words should either be bolded, underlined, I prefer bolded, or highlighted, mostly bolded or highlighted. So that way, because on our exams we're going to have like a matching column section. So it's easy just to find all those words. So okay, we're going to start, before we start with this lecture, what the heck is chemistry? Chemistry is the study of matter and the changes it undergoes. So this is why we start with matter. So what is matter? Matter is anything that has mass or takes up space. So long ago, these ancient scholars believed that matter composed of four things: earth, water, air or wind, and fire. So you know, the basic things we see every day. And many believed matter matter couldn't be like if we kept, okay, so listen, if I had like a piece of clay and I kept dividing, the last thing that could not divide was atoms. So let's talk a little about something. So let's think about how it is back in the day. So they have these thoughts about random stuff, but they had no method of actually testing. That's like the privilege we have today. We can test stuff and make people who make cool machines to help us test things. So prior to the 17th century, researchers were thought of as natural philosophers who relied on method of deduction reasons to explain the world around them. So the research they did was them thinking about stuff. And even in physics, it's the same thing. They think there's certain things we can't see, certain things we don't have the privilege of proving. So the first known method of research was just thinking. They really thought and like used whatever they had available to like just think of stuff. And the first guy we're gonna look at is Democritus. So he lives around 460 to 370 BC. And so this guy, he's the first person to consider what everything is made out of. So he said everything that is visible was made out of something invisible. And he coined the term atomos, A-T-O-M-O-S. atoms. And in Greek, that means indivisible. And so we know this today as atoms. That's our translation of atomus. So he was the first person to propose that matter was, again, indivisible, infinitely divisible. So if we had a percentage, we kept breaking it down, and the last thing that could not be broken down was an atom. So that's what he believed. He said that atoms were this solid, homogeneous, indestructible, and indivisible thing, and atoms had different sizes and shapes, and depending on the size and shape and movement determined the properties of that atom. So in life, no matter what we do, there's always going to be haters, and this one hater that we know today, that this man is a god in philosophy. His name is Aristotle. Around the same time, he's like, you know what? He's like, I don't believe you, Democritus. I have my own thing. So he didn't believe that atoms composed, that empty space could exist. So he said that something that was visible, because all things that are visible are made of something visible, as opposed to invisible. Because the atoms are invisible outside. But he said everything is made of something that is visible. And the four things that he said that things could be made out of, again, what was thought for many of years. Matter is made of earth, fire, wind, air, and water. Let's go back. So for these ancient scholars, so they all agreed with Aristotle, and this was the general consensus for like 1,200 years until a man of my own heart. If I was alive back then. Okay, before we get into it, this is Democritus, this is Aristotle, so I'm going to leave the slide up for a second. You guys can pause here to write down these notes and add it. You could put in the graph if you want, the philosophers and their main ideas. I thought this was a nice table, I believe, from one of the textbooks. So yes, a man from my own heart, Mr. Green Eyes himself. Look at this face, John Dalton. Look at that face. How could you not love him? If I was alive, that would be my boyfriend back then. So in the 1800s, this genius, handsome fellow over here, unlike people back long ago, there were some, advances in science. Not some, there's actually a lot, but enabled him to actually come up with a way to determine the mass ratio of elements. And he sat there and studied a crap load of chemical reactions, as well as people's research. Sorry, give me a second. Yeah, so a bunch of different researches, and he also agreed with Democritus. So he thought that matter is composed of these tiny particles that we call atoms, and that it was indivisible and indestructible. So this guy, first of all, he was an English school teacher, I believe, in England. Yeah, and he is the father of atomic theory. This guy is amazing. So he based on these bunch of the research that he did, it resulted in this thing called Dalton's atomic theory. It's not a little thing. It's basically the birth of modern atomic theories. It's just our own field of study, and the basis of chemistry. So continue with this. So there are four main components to his theory. So he says what? All matter is made up of atoms, and all atoms are indestructible and indivisible. Next thing, all atoms of a given element are identical in mass and property. So he's saying all carbon atoms are the same in their mass and in what they can do, its properties, which we will get to when we get to periodic table. And then he said compounds are formed by a combination of two or more kinds of atoms. So he's saying when you combine different atoms, it creates a compound, and then a chemical reaction is just a rearrangement of atoms. So this is just the formal writing. You can do both. You can write this and then just say it in my words. So when he says the third part, I thought it was a little bit hard to like understand, but it's like different atoms combine in whole number ratios to form compounds. So when they say whole number ratio, they say that like if you can't do half an atom. It's just that if you combine one atom, it creates a compound. If you combine three, it's another compound. And so you could combine a bunch of atoms and make compounds. It's pretty cool. So let's talk about laws of conservation. So Dalton's theory. Dalton's theory explains the conservation of mass in a chemical reaction and the results of separation, combination, and rearranging. So basically he's saying that the mass is conserved in a chemical reaction. So we have two elements. If we put them together, if we have two elements, no matter which way we combine these like sets of elements, the mass will always be the same. And this is based on this handsome French chemist. I'm going to try to do my best French accent. If you're French, sorry if I offend you. Antoine Lavoisier. So that French chemist, he created this law of conservation, and law of conservation of mass states that mass is conserved in any process, such as a chemical reaction. So the mass does not change, is always the same. We're actually going to do an activity just to reinforce that, so that, because people, they think, if I start with a certain amount of elements and I make a new certain amount of elements, it's going to be, two different masses, but it's not. So, yeah. Okay, let's look at this. So, again, going more in depth about this law of conservation of mass. So, we have this element A. So, its total mass is 4, right? For element A. We're assuming that it's 1 gram. Each of these blue things are 1 gram. And then we're saying, and now that we have this atoms of element B, and this total mass, whatever, it's 4 of whatever that mass is A. So let's say this is 4. Okay, we'll say this is 2 grams, right? So we have 4 times 2 grams is going to equal 8. And then we have 8 of these 8 atoms of element B. We'll say each of these things are 1 gram. And then this total mass is going to be 8 times 1 gram, which is going to be 8. So we have 8 plus 8. And then if we combine them, so its total mass of this is going to be, 8 plus 8, so all of it's 16. So we're saying that the mass of these elements on this side is 16, and the mass of these elements on this side is 16. So mass is conserved. It does not change. So mass is always conserved. And I think this is the end. And this is the end. So this is the end of your first lecture. Guys, remember to post. I'm going to go back because I hate blank space. Remember to go online. Let me actually go on the website for those who haven't looked at it. And please go, guys, sign up on Remind. So we're going to go to homework. We're going to click Unit 1. We're actually on the page. We're going to scroll down. We're going to do Section 1. The video is going to be around here. When I post it, you're going to put your name, blah, 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 and your last name, so I know who you are. You get credit for your homework. And you're going to post question 1. I'm to question 11. Whoopsies. Question 1. Boom, boom. Question marks. Don't forget punctuation. Boom, boom, boom. Next question. Question mark. As you can see, is 2:14. So hopefully it's posted by 5. It takes forever. Then you need to click submit. Boom. So for those who are not on Remind, whoopsies, I just submitted. It's fine. For those who are not on Remind, please upload it. And if in case you don't have whatever, guys, everything I give you guys, I try to post up here. Yeah, so this is just whatever. So you see the syllabus, you see the course, whatever. Oh, I don't know where I put the Remind instructions. I should have them here. Oh, contact. Go to contact. So if you want to contact me. So these are office hours. I haven't decided yet. My email, that's how you post an email. And then to be on Remind, the Remind instructions are going to be in contact. So unlike my living environment and bio class, I did your site first because I have 3 of this class. So I felt like it was more pertinent to have this up. If you see, I'm going to go to my ecology, like there's nothing there. I'm actually going to have to do that tonight. And Bio 101, their site isn't even published yet. So you guys are lucky. You guys will get it first. You guys have a great weekend. Remember to think about what happened. I don't know if some of you guys were even alive for this. It was 15 years ago. You know, this is one of the biggest tragedies that happened on American soil in recent years. And I guess I hold it near dear to my heart-ish because, one, I had people affected by it, but also it's something I was alive for. When we learn about history, it's just like, you know, way back in the past. But yeah, sorry to be a downer, guys, but have a great weekend anyway. I can't wait to hear about your day when I see you guys. Okay, I'm gonna end this video now.